first, now having shown you some of this, will already be in the paper that we'll discuss. For now, I would actually like to shift gears a bit and, before entering this, talk about the kind of frame, kind of model that is actually being used in that paper. The kind of frame that Thomason in his article recommends or develops, discusses, and that his other paper is based on, right? So on the handout, page 11, where it says technicalities, there I actually define a model like this in a way. So let me start from scratch. I would like to go through these definitions in some detail. I hope that's useful and enjoyable, perhaps. So okay. Let's not even talk about this Occamist truth versus Peircean truth right now, although this will be important in the end. Now let's go down to definition 1 on page 11, this T times W frame. As you can see, it has it's a structure consisting of 4 things: W, T, this, and this. And now we have already seen this is the same earlier than relation. We have worlds and times now in the same model, right? And then there's this other relation that we haven't yet talked about. But okay, let's see. So for now we only know about these 2 things. But I can already show you that the idea is that the worlds are lined up like this, right? So we have W, W prime, and so on. Okay? Intuitively, they aren't really lined up. There is actually no order between these worlds, but it's useful to think about them in this way, in this 2-dimensional way, because the times, they are in fact lined up in a linear order like this. And we have T1 here, T and T1 and so on. Okay? And now we have pairs, world-time pairs. You know, for example, W and T is here. Each point in this plane has 2 coordinates, a world and a time, right? So, you know, this one has these things, and so on. So we can talk about world-time pairs, which we can actually express something like WT, and then we have W prime, T prime, and so on. Okay, that's the idea. That's what the model looks like. That's that's the way to think about it, so it makes sense. Okay. And then we have these 2 relations, and the first one, the one on T, is the earlier relation that we have already seen. It is a reflexive and transitive and linear, which is the same as saying irreflexive, transitive, and connected. That is, there are no loops and no branches on this line. Time itself is just this, right? There's no order on these worlds, as I said. Okay, and this other relation is pretty important. This one. Let's see what it says. For all times T, this I don't know how to call it, squiggly T. In LaTeX, it's never mind. This is an equivalence relation. What does that mean? Well, let's see. So this order actually, whereas this here, remember, was a subset of T times T, right? Here we have a subset of W, oh sorry, oh wait, what was this, right? It's a ternary relation, three members, okay? that means every member of this relation is something of this kind, you know, T, W, W prime, whatever, something like that. Which would mean in this sense that here at T, for example, if this is a member of the relation, that means here we have this link at T from W to W prime, right? Okay. Now if you fix the temporal parameter, if you say let's only look at one particular time T, then the relation becomes one between worlds only because the time is fixed. So you look at one time slice, okay, and then you have links like this going back and forth. You know, this is the relation at this particular time. Does it make sense so far? The relation between worlds at some particular time, and these arrows, they go around like crazy because it is an equivalence relation. An equivalence relation is reflexive. So this is an equivalence relation. Symmetric and transitive. Transitive. That means one thing, well, reflexive for one thing, right? Already know, every world here has these loops, so there are these loops all over the place, okay? Reflexive. And then symmetric and transitive, that means if you go this way, you come back, and if you go there in 2 steps, then you can also go there in 1 step, and so on. However, that doesn't mean that all of these worlds are interconnected. If there is a break, so to speak, here, say, or you can have this kind of break where the following happens. You have all these accessibility links, and down here you also have lots of accessibility links, but nothing goes across. Okay, they are totally isolated from each other. That's what it means to have different equivalence classes. Okay, and if there were one link from here to here, then they would all have to be linked in order for the relation to be symmetric and transitive, and you can check that for yourself. So either you have no link at all going across, or you have everything linked. And any 2 sets of words are like that. Either nothing going across or everything linked. In here, in this, yeah. So, for example, this is one class of these completely linked worlds. And then we have another one here, okay? So, the relation at T holds between all of these. And this is the relation of being a historical alternative, right? One of these possible futures from time T. So the idea is, and the definitions will make that clear, the idea is that within here you have variation in the future, but they are all the same, they all share the same past. That will then come in as a condition on the truth value assignment. For now we only fix these relations. Okay. All right. So, and this also, an equivalence relation partitions the set of all these worlds. That is, if you go, you know, if this is our whole space of possible worlds, then we get these sets which don't overlap and exhaust all the possibilities. Okay. Now, so far, so good. Any questions so far? The next condition, number 2, the last line of this definition says, for all T and T prime, such that T is T prime, what did I teach this earlier? Okay, for all T and T prime and work pairs, if this relation holds here between these 2 worlds, and then it holds goes the other way as well. So suppose we have here two worlds like this. Actually, let's use W and W prime. At this time, then it also holds at all earlier times. That is, if you look at this time slice here, this snapshot of history, and call this T prime, then these links have to be here as well. So this has to be here. And likewise these and all of this, right? So all of these things have to be linked up in the past. And they must always have been like this at all earlier times. So you get, for the earlier time, you get an equivalence class that is at least this. But it may be bigger, of course. Right? So this ensures that two worlds that are alternative possibilities here, they have always been alternative possibilities. What this creates something of a kind of a structure that looks a bit like this. So once you are here and you know what this is, you know, you have all these links here. They are here at every earlier time as well. That's the idea. Okay. Right. Yeah. And if that were not the case, well, yeah. So what you can have, of course, is that at the earlier time the relation was not only this, but more. So you can have actually links going. You have to have at least these. You can have more, but then they have gone away here. Okay. So as in a way, the history has for this world, right? At this point, this chunk here was an open possibility. I mean, these worlds could have developed into this direction, but now this is ruled out. So there's a whole equivalence class here which has no connection anymore across these. And that's okay, because if you don't have a link here, there's not required to be on here, absent here. It can be here and not here. But if it is here, then it also has to be in the past. Right? So links are lost. These arrows are lost through time. That's how time proceeds. By eliminating arrows from this accessibility relation. And as we said before, in the past, with regard to these linguistic examples, in the past there were more open possibilities than there are now. That's why we have these counterfactuals that become false or whatever. Remember that, right? That's what this means. That's all. In the past, so if you only look at W, the alternative histories at this earlier time, there may have been many more of them than there are now. Okay. And if you go back and ask what was possible at the time, you see all of these. This becomes your modal base when you ask what was possible. But from the present, when you ask how can it have been, you only consider these cases. All right, so this is imposed on this relation here. I'm drawing this block here because this will then have a bearing on the truth values of sentences. In fact, however, we see that it came about a bit like this. At the earlier time, this was also these were also alternatives. Maybe there were some up here as well. So we have this shrinking set of possibilities as time goes on. And you may find it easier, I don't know, you may find it easier to think of this in terms of branching time, a tree-like structure. And this loss of possibilities corresponds to a pretty simple, clear structure. So here you have all these alternatives that agree on everything. That is, the truth values of atomic sentences in here. You cannot distinguish between them. The past is what it was. There are no two ways about it. Well, let's talk about this in a second when we actually have the truth assignment. So this is the structure as you may want to think about it right now. Definition 2 is nothing special. It just says, rather than writing these coordinates as pairs, world-time pairs, we might as well give them just single letter names like I and J, have variables over those. If you are familiar with Montague's grammar, PTQ and so on, you will know that he did it that way. In Montague's grammar, past and modality and so on are evaluated with respect to indices. An index, I or J, is a world-time pair of this kind. And he had, by the way, also these operators, past and future, and necessity. But necessity was a weird thing in Montague's grammar. He didn't worry about modality so much. There, necessity, necessarily P, was true here, if and only if P is true at every index, past, future, here, the whole, always, necessarily. That's not what we want, really, right? Just in case you're familiar with this, this is how it's related. So now we can also write I and J and so on for these things. These points in this space, I, J, and so on. And then these relations are defined between them in the obvious way. And now this condition on truth assignments. Am I too fast? How's it going? It's okay. Yeah. Now the condition, let's definition 3, let's look at that as well. This says nothing more, first of all, that you add to this frame evaluation function v. Okay. You have this TW frame, and then you add a function v, which takes sentences and returns, in this case here, returns functions from these points to truth values. From these points to truth values. So there is almost no constraint on this truth assignment except, and that's important, that at any given time, like here, if, so now this is only about the atomic sentences of the language. If P, or does it have A here? Let's stick with P. We've used P all along. If P is true here, then it must also be true at all these alternatives. That's what the condition says. So if you have P true anywhere, then P is true all over the place. If that's not the case, then it's not an acceptable truth assignment. Okay? And if you think about what that means, so P, here you have P happening all over the place. In particular, all of these worlds are P worlds. Later on, there was a time here where Q was true at all of these worlds, but maybe not at the others. Here, maybe Q is false here. here. What does that mean? Well, between these two times, back here you thought that Q might come out false. From now on, Q can no longer be false. Does that make sense? So back here, from this time t prime, not Q was an open possibility. One of the possible futures, all of these, these are all alternatives, and some of them have Q false. Right? At this time. So you don't know whether Q will be true or false. And back here, you don't know whether it will. But once you're here, you know it's fixed, it's settled. The question has been resolved. Q is true and not false, period. And from then on, it will always be such that Q was true at this time. So from the perspective of this, where we even have fewer worlds, as this becomes narrower and narrower, Q can never become false again. It has been the case, so it will always be true that it has been the case. And now we can compare this to trees, because you see now, in here, for example, within this block, as pink here, and all of these time slices, the worlds are indistinguishable, right? All the truth values are constant here across these guys. So if there's another one R here, say it was false, so it's false everywhere. There's no atomic sentence at any time that lets you distinguish between these alternatives, right? They all make every sentence here at every point in this thing is either true in all of them or false in all of them at this time slice. So here we can say that the language does not distinguish between these alternatives. If you have a branching tree structure, then the intuition is only slightly different. Then you don't say that the language does not distinguish between these alternatives, but that they are in fact identical. They are the same thing. There you say you have just one past, multiple futures. That means here something like up to t prime. Should I actually give this a name here? T double prime. Q might have turned out true, right? Yeah, true. Here it's false. So it encodes the same thing, that if you are now at this present time, then there's only one possibility, Q was false, right? But in the earlier days, it might have come out true. If you see the connection between this picture and this picture, it should be pretty easy to follow. So here, think about it as, so each of these paths through the tree, am I too low down? I'm sorry, I should draw this somewhere higher up. Here, I don't know, so you have a tree like this, okay? Each of the paths through this tree, for example, this one, right, or say this one, corresponds to a line here. So this is, as it were, you take all these paths and you spread them out over the paper like this. Disentangle these histories and lay them out in parallel. And just as everything here was, you had this, it was either P or not P, period. Likewise over here, when you spread it out, it's still the case in these past times. The truth value is fixed, P, for instance. So just disentangle, take this apart, lay them all out in parallel, and you get this model. And because as you progress here as well, you eliminate possibilities, right? At this time, this is still an open possibility. At this time, it's no longer an open possibility. So as you go through the tree, more and more of these alternative branches are ruled out, which is just the same as saying that more and more of these lines here are eliminated. You see that? It's the same thing. And we have this conditional truth assignments to make sure that they are in fact the same here. We have in fact only one past and not several different ones. Okay. So we have the progression of time by eliminating alternative possibilities that we talked about earlier, neatly encoded here. And now we can say that something is now it is now necessary in some sense, in the sense of historical necessity. It is now settled, where settled is a necessity operator that is sensitive to this relation. It is now necessary with regard to this relation that the sentence is true, right? But it was not necessary that it would be true. In the past, it was not necessary it would be true. And likewise, for example, that P was case, or say that Q was true at this time. That is still the case with regard to all these alternatives, right? And it will always remain true. But it was not necessarily the case earlier, because it could have turned out false. Yeah, so, okay, well, I don't know. Ask. I'm always stepping on this chalk here. If you don't have any questions, I'll move on. So far, we have only talked about this relation. It's tricky enough, but there is one more that comes in if you want to make this distinction between objective and subjective uncertainty, right? So if you don't have any questions about this, there's one more thing that I want to introduce into this model, and then I think that will be all in terms of complexity of the model. And then we can talk about the way sentences are interpreted in there. So there's one more relation then in definition. Where is it actually? Oh, definition 5. Yeah. And doxastic history, which is a history of a belief agent, someone, it models the development of someone's beliefs through time. Because we want to make this distinction, remember those conditionals, right? They can be true with regard to someone's beliefs, but objectively false or truth or without a truth value. So we need both of these accessibility relations, and they interact. Because the future cannot be already known. What is true, whether it rains, we talked about it, whether they say, whether there's the fact that there is no typhoon tomorrow could not be known 10 years ago, even though it was already true. And it's also possible that we don't know whether there was one yesterday, even though objectively, of course, either there was one or there was none. So there are not two ways about that. In the stochastic model, we just add this one relation to it, a doxastic accessibility relation. So we have here historical alternatives. Now we have boxastic alternatives, you know, ways in which the world might be for all you know, based on what you know. Okay. And this picture is getting a bit messy, so I'll make another copy. Let's see here. Objectively, there is no uncertainty about the past, right? So, you know, to the question, how many leaves were there on this tree 5 years ago out there? There is a definitive answer. There is some number n such that there were n leaves on this tree. No one knows how many, but we all believe that there is such a number and it's fixed, right? There's only one. Do you agree? Yeah. Or how many degrees, well, you know, how was the weather 1,000 years ago? I don't know. So these things are fixed, but we don't know what they are. What does this correspond to? Like I said, in this objective history here, all the past facts, they are constant, right? So there is some number n such that there were n leaves and so on. But if you don't know that, that means you have alternative possibilities in your epistemic accessibility relation. So one where there were 500 leaves and another one with 501, so on, right? That means that, okay, let's see. Again, if we look at just one world here, and at some time we have this accessibility really, or this equivalence class here of historical alternatives. Such that, you know, they go back like this. It's the same as over there. Now, epistemically, we don't know which one it is, so there are other objective histories with other worlds in them, right? There's a world V, perhaps. Draw these lines in a different color here, because this is supposed to distinguish between them. This is world V. So there were, oh sorry, do it this way here. Okay. So here again we have some equivalence class, and there is no link across. They are completely disjoint nowadays, as here at this time. And there's another one up here with worlds in there and so on. Each of them. Now each of these can have different truth values for some sentence P. We have P true over here. It's true at all of these guys, okay? But it may be false at all of these. So on. And likewise, perhaps up here, let's just say it's true all over the place. It has to be constant across each of these sets, but it can vary between them. It's not ruled out by the model. And so if you have a belief about, well, actually, if you have no belief in this, in a sense, if you don't know what the value of P was, whether P was true or false, that is modeled by saying that, well, somehow your belief state has worlds from here and from here, right? And perhaps here too. Anyway, there is some variation in your belief state. You haven't ruled out either case, P or not P. So the worlds compatible with what you're believing are a superset of each of these classes. Okay? And the definition fixes that. It requires that. You can see how it's done. Okay, but the idea is, if you don't know what P was, that means you have, something that comprises both of this. I'm not drawing it yet because there's one more requirement that comes in. But this should be pretty clear, right? So you have these blocks, as it were, the past, different ways of filling in the blanks in the past, the things that you don't know about. Here she was in her office, here she was not in her office. You don't know whether she was in her office or not, but objectively either she was or she wasn't. You think that is also true, right? You just don't know it. It's not like the world is such that the fact hasn't been decided yet. It is decided, you just don't know which way. Right. And now one more thing about the future. What can you know about the future? There, we can make this reasonable assumption that if something is not yet objectively decided, then you cannot already know it. We can't look ahead in history. We don't really know what the weather is like 2 weeks from now, right? Even though once we are there 2 weeks from now, it will be clear. There will be some particular description of the weather, but it's impossible to know what that is. We can know things that are already determined, like when the sun will come up. But where there is genuine uncertainty, objective chance, we cannot already know that. How do you represent that? That you cannot look ahead in history. I mean, this will really be important then in this interpretation of the present tense, for instance. Why the present tense with future reference gets such a strong reading and is often ill-formed or infelicitous. Because you cannot know already what will be the case. How do you model that? Well, again, knowing more means having fewer worlds in your knowledge state, having ruled out certain possibilities. You cannot rule out possibilities that are not objectively eliminated yet. So you cannot have a belief state that looks like this. Perhaps you have precisely this set of worlds, nothing else. Because that would mean you already know that these things cannot happen. But you cannot know that they won't happen because objectively, they are not distinguishable from these others up to here. You don't see what will happen. And they are exactly the same. They are indistinguishable up to this time t. So on what basis can you decide which of them are the actual ones? You don't know. So all these alternatives, since we cannot know what has not yet been determined, we cannot distinguish between these worlds, we have to obey this partition. We cannot cut across these equivalence classes. We cannot eliminate worlds like that. We can only, so an epistemic belief state can only have whole classes of this. So it is a union of equivalence classes. It can be more than one, but it has to have the whole block, as it were, not just some of it and not the others. That means, that's what it means, how we model this assumption that we cannot know the future. Ruling this out means eliminating these worlds. We can't do that because they look exactly like these others. Only God can know which world is the actual one. We will not know until we reach the end of time. Just kidding. But you see, do you get the intuition a little bit? Here, this is how it works. And this is in fact written into the definition. There are two conditions on these belief states. Well, there are actually some more. I'm sorry, but it says here it is in definition 5. This relation is historical and lacks foreknowledge. It's a bit cumbersome. It's a somewhat awkward formulation. But now let's go back and see what it means in definition 4. When is a relation historical? I call it that because that means it observes historical necessity. That's something I haven't said yet. But the idea here is that suppose we have we have W, okay? W in here. And we might say that this is the set of worlds at time t accessible from W. Can I write it like this? Is it okay to see what it means? So this is these are the beliefs that you have at t in W. That's your modal base. In this world, you have these things in your modal base. Okay? At time t, and then of course over time it changes. But at time t, you have these two things. W. And then you have some other world, W prime. And now something you cannot have according to this definition is, for example, this as your beliefs at W prime. That's what this historical thing rolls out. Why? Because these are alternatives, and just like they have to agree on all the atomic sentences, all the facts, they also have to agree on what you believe, because that is also a historical fact. You either believe or you don't believe P. At W prime, you believe that P is true. At W, you believe that P, you don't believe that P is true. You don't know. That's impossible according to this definition. If that's the case, then these worlds cannot really be historical alternatives. There is a difference between them. You believe something different in one and the other. So this definition says, if you look at it, historicity is historical if and only if I Rj and I squiggly k jointly imply k Rj. This is, for instance, from here, from this point, I should call this I and j, maybe that would be helpful. Let's call this point I. It's the same thing, but this is closer to what's written on the paper. So we have I here, this index. And we have this accessibility relation going to some index j. Right? Because it's in this modal base. And then we have a historical alternative of I here, say k. And it says, well, then if you have this link from I to j, then you must also have one from k to j. So what I just drew, the pink one is ruled out. Right, this thing here, you can't have this from, it can't be that these are your beliefs at k and these are your beliefs at I. They have to be the same. That makes sense, doesn't it? It means you either do or don't believe P. So
Could you explain the difference between the first column and the second column again?
Column.
I mean the yellow lines. First PPP and the second PPP.
Oh, well, there is some other fact. So perhaps why
So
are they?
there'll be
There is
true
some,
afterwards and
there is
and
also
first
here.
column.
No, there is perhaps R is false here and true here,
Okay.
something like that. So they are distinguishable, but P doesn't. So P is true at all of them. Yeah. So this is ruled out. All of these worlds, you have the same model. The modal base is the same across all these alternatives. That's all it says. Sounds simple. And it lacks foreknowledge. This is the second condition. B at the bottom of this page 12. If I are J and J is strictly K, then I are K. Let me get rid of these J and K because it is. No, sorry, then. If I are J, yeah. This rules out the other case that I talked about. Suppose this is your modal base. This pink one. Suppose the pink thing is your modal base. This cannot be, I argued, you don't want that because it would mean that you know more, you know something about the future, right? That isn't yet predictable. You have IRJ, okay. And then you have a historical alternative J, which is K down here, right? So you have IRJ. No, R of course is this thing, right? And you have J, K. Then you must also have the link from I to K. That's what it says. That's what the definition says. So this doesn't work. You have to link these as well. So the pink modal, the epistemic modal base has to capture all the historical alternatives of this index J. And it just, what we just did, it just means you must have, you can basically think of these as blocks, these whole classes, right? They are solid, as it were, like wood, and you cannot split them. In your belief state, you have some collection of these, but you have to take them as whole blocks. And this is also important for the interpretation of these sentences, because in the present tense, where you then actually assert, when you assert that it rains tomorrow is true at all historical alternatives, according, if there is this necessity modal in the tense, then it rains tomorrow is a necessity statement. It must be interpreted as necessity over all of these classes, and then someone may ask, how do you know that? So on. Okay, that's what it looks like. It's not so easy, I know. But let's look at some language actually. Now let's go to, there's one more condition, which I'll get to. Let's go to this other handout. We don't have to go through the whole handout because we have already covered much. There's some overlap. This is a different handout here. Conditional truth and future reference. So much of what I have said today is already in here, so we don't have to go through it in great detail. But okay. Before we turn to the way these models are now used, let's look at some of these examples that motivate the analysis. In one, there are these two sentences. If he submits his paper to a journal we won't include it in our book. And if he submitted his paper to a journal, we won't include it in our book. So one of them is about the future, the other one is about the past, right? The antecedents. And now the question here is in this box, what are the antecedents? This is in what sense to ask this question? Well, if we assume compositionally that these sentences are put together by taking two smaller clauses, right? Take two small sentences and you put them together with this conditional if-then construction, and you get this. What is the input to this operation? What are the sentences that you start out with? And well, you see it here. I claim it is precisely what you see. So the antecedent of 1a is he submits his paper to a journal, and the antecedent of 1b is he submitted his paper to a journal. And that is a very controversial claim. Usually this is denied in the literature. Why? Because if you actually use these sentences by themselves in 2a and 2b, you get this difference. It's okay in 2b. 2b, of course, you can use it the same way as in the conditional. There's no difference in meaning. But for 2a, you get this, what I already referred to, this certainty condition, right? He submits his paper to a journal. Means something like he inevitably, or it has been decided that he submits his paper to a journal. It is determined. That's the connotation that you get with 2a. And it's not there in the conditional in 1a. That antecedent does not mean if it is now decided that he submits his paper. At least it doesn't mean that necessarily. In Japanese, there's more going on in Japanese, but so it's not. It doesn't help if you think about translations like "karegaso no genko teitsu suruba" or "shitara." There you don't see this difference. I think you need something with tense in it, something like "surun dattara." Okay. "Karegaso no genko o teitsu surunda." In isolation. It's a bit different, right? It has this. It has been decided that he submits his paper. That's what it means, right? I think. I don't want to venture into this, but well, it actually means, I guess, pragmatically it means something like he ought to, or he, I don't know. Never mind. But perhaps you can feel this difference then, right? If you have tense. I'm not sure. If you have any reactions about Japanese, let me know. But it's quite clear in English there's this contrast. And many authors have claimed either that in 1a, he's, in the conditional under if, this he submits his paper in 1a does not even have a tense. It just looks like it has a tense, but it's not there. Some have claimed that. Others have claimed that you start out with he will submit his paper to a journal. And then you delete the will somehow. And why have people claimed that? Because he will submit his paper is a natural thing to say. Whereas he submits his paper in isolation outside of the conditional is not such a natural thing to say. Okay. Are there any questions about these examples here? So the claim that you have literally the same sentences that are interpreted in exactly the same way in the conditional and in isolation outside of the conditional. That is not such a trivial claim. It has, you have to tell some story about what the difference is. Why do we feel this difference? Okay. And then there's this additional little fact, which I should mention, although I don't have to go into it in great detail, but it's important. I just said that in 1A, you don't get this settledness or scheduling reading if he submits his paper, that you get with he submits his paper. But you can, if you put it in some context. In 4A, we will check what was decided. This is on the next page, right? 4A. We will check what was decided about these manuscripts yesterday. If that is the context, then the sentence, if he submits his paper to a journal we want to include in our book, actually has this scheduling reading, which you can paraphrase as, if it is decided that he submits his paper. Okay? So this is a there is some variation. This is a pragmatic parameter, right? And we'll see later on how exactly this works out. So I would like to say that semantically 1A and 4A are not distinct. It's only in the in some pragmatic parameter that they differ, and that's how you get the difference. And then for 4B, you can have this future and the past reading. We'll check next month to see which of these manuscripts are still available then. Next week. And then if he submitted his paper between now and then. Right. This submission of the paper for 4B, this doesn't have to be the past. If the context says next week, then the past tense can refer to the time between now and then, next week. You can in fact say, if he submitted his paper tomorrow, then we won't include it in our book. That's possible. So, and that needs to be accounted for too. And even there, I would like to say that 1B and 4B are also semantically the same. So, okay, well, is that so far? Oh, wait a minute. One more minute. Let's say we'll take a break, and then we'll have 1 more hour to go through this, okay? Think of questions so in the meantime. Thanks. Say something again about the intention here behind these examples.